Hello everyone, welcome to online lecture series on Fourier Transforms, lecture 8. In this lecture, we'll look into properties of Fourier sine and cosine transforms. The first property is linear property, which states that Fourier sine transform of a times f of x plus b times g of x is equal to a times Fourier sine transform of f of x plus b times Fourier sine transform of g of x. The same property holds for Fourier cosine transform also. So now let us look into proof of first point. We know that the Fourier sine transform of f of x is given by fs of s is equals to integral 0 to infinity f of x into sin sx dx. Now let us consider Fourier transform of a times f of x plus b times g of x. By definition of Fourier transform, it is equal to integral 0 to infinity a into f of x plus b into g of x into sin sx dx. Now multiplying the terms, we get integral 0 to infinity a into f of x into sin x plus b into g of x into sin x dx. Taking outside a, we get a into integral 0 to infinity f of x sin sx dx plus b into integral 0 to infinity g of x sin sx dx. And integral 0 to infinity f of x sin sx dx is Fourier sine transform of f of x. And integral 0 to infinity g of x sin sx dx is Fourier sine transform of g of x. So we proved that Fourier sine transform of a into f of x plus b into g of x is equals to a times Fourier sine transform of f of x plus b times Fourier sine transform of g of x. The result for Fourier cosine transform can easily proved, so it is left as an exercise. The second property is change of scale property, which states that if Fourier sine transform of f of x is denoted as fs of s and Fourier cosine transform of f of x is denoted as fc of s, then we have these four equalities, which states that Fourier sine transform of f of x, f of ax is equal to 1 by a times Fourier sine transform of s by a. Similarly, Fourier sine transform of f of x by a is equal to a times Fourier sine transform of fs of as. Similarly, Fourier cosine transform of f of ax is 1 by a times Fourier cosine transform of s by a, and Fourier cosine transform of f of x by a is a times Fourier cosine transform of as, where a is positive in all the cases. Now let us prove these equalities. First one is Fourier sine transform of f of ax is 1 by a times Fourier sine transform of s by a. So to prove this, we consider Fourier sine transform of f of ax. By definition of Fourier sine transform, this is equal to integral 0 to infinity f of ax into sin sx dx. Now let us substitute ax is equal to t. So upon differentiating, if ax is equal to t, then a into dx is equals to dt. Therefore, dx is equal to dt by a. Now if we substitute this in this equation, we get fs of f of ax is equal to integral 0 to infinity f of t into sin s t by a dt by a. That is equal to 1 by a times this a is taken outside as 1 by a into integral 0 to infinity f of t sin t into s by a dt. That is equals to 1 by a into fs of s by a, because fs of s is equals to integral 0 to infinity f of x into sin s x dx. Here in place of s, we have s by a here. Therefore, this is equal to fs of s by a. So we prove first point. And the second one is fs of f of x by a is equal to a times fs of as, where a is positive. And in 1, if we replace a with 1 by a in the above equality 1, then this 2 can be easily proved. And 3 and 4 are left as an exercise to you. In place of Fourier sine transform, we just consider Fourier cosine transform. So it is easy to prove them. Now let us go to another property, the modulation property, which states that Fourier sine transform of f of x into sin ax is equals to 1 by 2 times Fourier cosine transform of s minus a minus Fourier cosine transform of s plus a. Similarly, Fourier cosine transform of f of x into sin ax is 1 by 2 times Fourier sine transform of s plus a minus Fourier sine transform of s minus a. And Fourier sine transform of f of x into cos ax is 1 by 2 times fs of s plus a plus fs of s minus a. And Fourier cosine transform of f of x into cos ax is 1 by 2 times Fourier cosine transform of s minus a plus Fourier cosine transform of s plus a. So let us prove the first point, that is Fourier sine transform of f of x into sin ax is equal to 1 by 2 times fc of s minus a minus fc of s plus a. For that, let us consider Fourier sine transform of f of x into sin ax. By definition, it is integral 0 to infinity f of x into sin ax into sin sx dx. That is equals to integral 0 to infinity f of x into sin ax into sin sx dx. Now let us multiply and divide this with 2, so that it becomes 1 by 2 times integral 0 to infinity f of x into 2 sin ax into sin sx dx. Now let us apply the formula 2 sin a sin b is equal to cos a minus b minus cos a plus b here. So we get 1 by 2 times integral 0 to infinity f of x cos of a minus b into x, that is cos of s minus a x minus cos of s plus a x dx. That is 1 by 2 times integral 0 to infinity f of x into cos of s minus a into x dx minus integral 0 to infinity f of x into cos of s plus a x dx, which is equal to 1 by 2 times fc of s minus a, because this is definition of Fourier cosine transform. So it is fc, in place of s we have s minus a here, therefore this is fc of s minus a, and here in place of s we have s plus a, therefore this is fc of s plus a. And the proofs of 2, 3 and 4 are similar, so they are left as an exercise to you. And these are some useful formulae here to prove 2, 3 and 4. Now the next property is fs of f dash of x. Fs of f dash of s is equal to minus s times fc of s, where fc of s is Fourier cosine transform of f of x. And fc of f dash of x is equal to minus f of 0 plus s times fs of s, where fs of s denotes Fourier sine transform of f of x. Now let us prove the first equality. So for that, we consider Fourier sine transform of f dash of x. By applying definition of Fourier sine transform, we can write it as integral 0 to infinity f dash of x into sin sx dx. Now combining f dash of x and dx, it can be written as d of f of x. Now we will apply integration by parts for sin sx and d of fx using this formula. So that becomes sin sx into f of x within the limit 0 to infinity minus integral 0 to infinity f of x into derivative of sin sx is s into cos sx dx. That is equals to 0, the first term becomes 0, assuming f of x tends to 0 as x tends to plus or minus infinity. So first term becomes 0. So we are left with minus s into integral 0 to infinity f of x into cos sx dx, that is minus s into integral 0 to infinity f of x into cos sx dx is Fourier cosine transform of s. So this completes proof of first one. And let us look into proof of second one also, that is Fourier cosine transform of f dash of x is equal to minus f of 0 plus s times fs of s. The proof goes in a similar way as in one. So we will consider fc of f dash of x, that is integral 0 to infinity f dash of x into cos sx dx, that is Fourier cosine transform of f dash of x. Now f dash of x and dx combinedly can be written as d of f of x. Now applying integration by parts using this formula here, we get cos sx into f of x within the limit 0 to infinity minus integral 0 to infinity f of x into derivative of cos sx is minus s times sin sx dx. Now if we apply the limits for the first term and assuming that f of x tends to 0 as x tends to plus or minus infinity, the substitution of upper limit gives 0 minus, we substitute lower limit, then that is x is equal to 0, we get cos 0 as 1 into f of 0. Therefore, the first term is minus f of 0 plus s times s into integral 0 to infinity f of x into sin sx dx. And integral 0 to infinity f of x into sin sx dx is Fourier sine transform of f of x, that is fs of s. Therefore, fc of f dash of x is equal to minus f of 0 plus s times fs of s. And the next property is fs of x into f of x, that is Fourier sine transform of x into f of x is minus d by ds of fc of s, that is minus times derivative of cosine transform of f of x. Similarly, Fourier cosine transform of x into f of x is equal to d by ds of fs of s, that is d by ds of Fourier sine transform of f of x. Now let us prove the first equality, that is Fourier sine transform of x into f of x is equal to minus d by ds of Fourier cosine transform of f of x. For that, we will start with the right hand side by considering Fourier cosine transform of f of x, that is fc of s is equal to integral 0 to infinity f of x into cos sx dx. Now let us differentiate this equation with respect to s. Then what we obtain? D by ds of fc of s is equal to d by ds of integral 0 to infinity f of x cos sx dx. Now using Leibniz rule of integration, this derivative goes inside the integral as a partial derivative. So it becomes dou by dou s of f dash of x in f of x into cos sx dx. So that is equals to integral 0 to infinity dou by dou s of f of x into cos sx dx. And dou by dou s of f of x into cos sx dx is f of x into minus x times sin sx dx. So that can be written as minus integral 0 to infinity x into f of x into sin sx dx. That is equal to minus Fourier sine transform of x into f of x. So what we have proved? That Fourier sine transform of x into f of x is equal to minus d by ds of Fourier cosine transform of f of x. And the proof of second part is similar. So it is left as an exercise to you. So these are some important properties of Fourier sine and cosine transform. Hope you all understood the video. Thank you for watching. Thank you.